Okay, second topic, statistical significance versus practical importance. These are two separate questions. You have to ask, is it statistically significant? The only thing you're asking when you're asking, is it statistically significant, is that's it. Remember, your p-value is the probability, if the null hypothesis is true, of getting a sample like this. So you're really asking, if the null is true, how often will I see a sample like this? If I will rarely see a sample like this if the null is true, then I reject the null hypothesis, and then my results are statistically significant. Statistically significant. So if something is statistically significant when p is less than or equal to alpha. So that's what we ask, is p less than or equal to alpha? Sometimes statistical significance depends on your choice of alpha. Let's say all we know is that something is statistically significant at alpha of 0.05. So if we know it's statistically significant at alpha equals 0.05, what we know is that p is less than or equal to 0.05. That's all we know. So the question is it also statistically significant at alpha equal to 0.01? And what about significant at alpha equal to 0.10? Well, we know this because we know it's statistically significant at 0.05. So the question is, if the p-value is less than or equal to 0.05, how does it compare to 0.01? How does it compare to 0.10? Well, this one is easier, right? If we know that p is less than or equal to 0.05, it has to be less than 0.10 because all the numbers less than 0.05 are less than 0.10. So it's always significant at 0.10 if it's significant at 0.05. But that's not true about alpha of 0.01. If p is less than or equal to 0.05, it might be less than or equal to 0.01. Maybe we have something like 0.001 that is less than or equal to 0.05 and is less than or equal to 0.01. But maybe we have something like 0.02. 0.02 is less than or equal to 0.05, but 0.02 is greater than 0.01. So if we know that p is less than or equal to 0.05, it's significant at 0.05, it may or may not be significant at 0.01, but it's definitely significant at 0.10. What if all we know is that it's not significant at 0.05? At alpha equal to 0.05. Well, then we know that p is greater than 0.05. Well, now what do we think? Is it significant at 0.01? And what about 0.10? Well, now this is the easy one. If our p-value is greater than 0.05, it has to be greater than 0.01. If p is greater than 0.05, it's always greater than 0.01. Here's the one that's not so clear. So if it's greater than 0.05, it is maybe greater than 0.10. I mean, maybe it's something like 0.06. 0.06 is greater than 0.05, but less than or equal to 0.10. But maybe it's something like 0.23. That's greater than 0.05 and greater than 0.10. So significance may depend on your alpha. It can be significant or not significant at one level of alpha and not at another. If you increase the sample size, you are going to decrease the p-value, and there's an example in the Chapter 21 handout. So if you decrease the p-value, you're more likely to get under alpha, you're more likely to have statistically significant results. Always give the actual p-value so people can see how it compares to maybe the alpha that they want to use, and they see how much evidence you have against the null hypothesis. A very low p-value like 0.000001 means that you get a sample like this only 1 in a billion times if the null is true. Whereas if you have a p-value of 0.049, well, now you'd see something like this almost 5 out of 100 times just by chance if the null is true. Much more likely. So you should reject the first. You have a lot more evidence against the null with the first one than with the second one. What about practical importance? Well, practical importance, you go ask the scientist. Is this a difference that matters? Is this big enough to be important. So that's not a question that the statistician can answer. So the hypothesis test answers the first question, is it statistically significant? But the scientist answers the second one, does this matter in any practical sense? So you always have to ask both questions. The problem is that historically, people assumed if it was statistically significant, then it mattered in a practical sense. And that's just not the case. It could be statistically significant, but not practically important. The difference could be too small to matter, or it could be not statistically significant. P could be greater than alpha, but that's the important story. Maybe there are no new side effects for a new drug or something like that. So these are separate questions, and you have to ask them of different entities. Is it statistically significant? Ask the hypothesis test. Does it matter? Ask the scientist, because those answers don't always correspond.